Hello, in this video, we will introduce virtual functions and dynamic binding. We'll fix the problem raised in the previous video. In the previous video, when you run the program, you pass so-code to geometric object, you invoke the toString function, you always get the geometric object toString function. We can fix it. The way is really simple. In C++, we're going to have this virtual function. In the base class geometric object, we're going to define the virtual function, the keyword virtual. By using virtual, it enables dynamic binding. So .toString, the G.toString, the geometric object .toString, is going to be dynamically determined at runtime. See exactly what G is. If G is so-code, so-code's toString is going to be invoked. So what we do is all here. In the geometric object class, now we rename it as geometric object with virtual toString. It is defined using virtual now. It has virtual. So this is geometric object with toString and the header file and also .cpp with this geometric object with virtual toString. Now, so we're going to go back to this program here. We're going to use, instead of using this geometric object.h, so we're going to use geometric object with virtual toString.h. And now you're going to run this program, you're going to see that the geometric object is displayed if you pass geometric object. If you pass so-code, it displays so-code object. If you pass rectangle, it displays rectangle. So this is here, the G. Now, you can write it this way here. We're going to have this is passed by reference. So you can, this is the one here, G.toString, and here, so we have this geometric object. This is, you're going to pass by reference. When you do pass by reference, let's do it this way here. We're going to have the geometric object. This is, let's call it G1. So here is G1. And now this is going to be so-code. Let's call this as C. And the rectangle object R. So how about using this 4, 6? So this is R. And this so-called, let's use 5.4. So this is C right here. Now let's run this program now. Run it and see what happens. So you get it correct now because you're using geometric object with virtual toString. Now, if you don't use with virtual toString now, you run the program, see, you get all the geometric object, geometric object, geometric object. So another thing is here. If you simply have this G here, G right here is passed by value, it's not going to work. You still get geometric object, geometric object. So this is, it has to be pass by reference or using the pointer. So if using pointer, so this will be all right. This should work. Okay, or like what you did before with this is all going to be fine. But pass by value, pass the object, that is not going to be dynamically bounded at runtime. Let's review some important points here on virtual function. If a function is defined virtual in a base class, it is automatically virtual in all its derived classes. The keyword virtual need not to be added in the function declaration in the derived class. Matching a function signature and binding a function implementation are two separate issues. The declared type of the variable decides which function to match at a compile time. This is static binding. The compiler finds a matching function according to parameter type, number of parameters, and the order of the parameters at compile time. A virtual function may be implemented in several derived classes. C++ dynamically binds the implementation of the function at runtime, decided by the actual class of the object references by the variable. This is called dynamic binding. So this is dynamic determined at runtime which function is actually going to be invoked. If a function defined in a base class needs to be redefined in its derived classes, you should define it virtual to avoid confusions and mistakes. On the other hand, if a function will not be redefined, it is more efficient not to declare it virtual because more time and system resource are required to bind virtual functions dynamically at runtime. We call a class with virtual function a polymorphic type. So this, you have that function here. So that is a polymorphic type. That is all for this section on virtual functions and dynamic binding. See you on the next video.